We're going to take a look at bivariate data and scatter plots specifically with that, and what's the association and how we can tell what's going on with scatter plots. Well, first of all, let's kind of go through some definitions. We know a scatter plot is points plotted to show the relationship between two sets of data. It can determine if there is a relationship or association between pairs of data. So first of all, let's break this down. It's a graph, and we all can agree that right here in front of us is that we have a graph. Now, there are points plotted on it, which we can see. All these points are plotted on it. And it shows a relationship between two sets of data. So let's talk about what those two sets of data are. We notice on the x-axis is one set of data, which is pages in a novel. And on the other is the times checked out from the library. We're talking about how many times a book is checked out from the library, because that's the title of our graph, pages in the novel and times checked out from the library. So those are kind of giving us what our data sets are about, and we put one on the x-axis and one on the y-axis. And what we do is we get information and we plot that information on the graph. Now, we do have this thing called an outlier. An outlier is a data point that's very different from the others. And when we talk about an association, which I'm going to get to in a second, we don't consider it in that part. So if I'm kind of just looking at this data and I kind of notice everything's all clustered really nice together, there's a point sitting way out here. This point out here, this is the outlier. Okay? That outlier out here really isn't helping us with our data. So let's take a look and see what this data is about. If we take a look at the graph here, it's like giving us some examples, such as a page of a 200 pages novel gets checked out about 19 times. We can also see that a 280 page novel gets checked out 10 times, 320 gets checked out about 10 times. And as it gets more pages in the novel, for example, down here, where there's about, 410 pages, it gets checked out about twice. We notice that the bigger the novel, or the more pages in the novel, times checked out from the library get less and less. Now this outlier here, obviously it's a piece of data. For example, that could be the book Hunger Games or Twilight, something that people are very interested in, but not something that would normally would have picked up to read. And that's why we get that outlier sometimes. But we can take a look at this and we can tell that something's going on. So as the pages in the novel increase, we know the times that check out from the library, they decrease. And we can see that these have an opposite relationship. When we talk about an opposite relationship, we're talking about a negative correlation. As one thing goes up, something else comes down. So as one data set increases, the other decreases. A positive correlation, but they would both be increasing together. Okay? Now they could both be decreasing together as well. Basically, they're going in the same direction. Now here, we have something which is no obvious correlation. In other words, there's nothing that really in one data set, it doesn't really affect the other data set, so we really can't see any type of relationship whatsoever. So if we go back and take a look at what we were just talking about, pages of novel and times checked out from the library, because one goes up and the other goes down, they're opposite of each other, we see that there's a negative relationship involved between the pages in a novel and the times a book is checked out from the library. Let's take a look at a couple of more examples. This one specifically, work experience and wages, and those are our two data sets. One is the years of work experience and the other is hourly wages, and we notice that's in dollars. Let's kind of take a look at the axes for a second, and we'll go back and look at the first one as well. Here we notice on the x-axis everything is going by 1, 2, 3, 4, and so forth. So everything is increasing by 1. On the hourly wages, though, we're increasing by 5. So this is $5, $10, $15. So different increments. So we have to be very aware when we're doing scatter plots that our gauge of measurement isn't always set the same. We can look again here on that first one. We notice the pages in the novel jump by 40 each time, where the times it was checked out from the library only increased by 2. This helps us to condense the data and put it together so that we can see if there's any kind of relationship whatsoever. We also might come across like this, where it has a squiggly line, which means that we aren't really going to see any data until about the 130 mark. So there's no point in having a big blank part in the graph. If we were to have all of these here, there'd be a big giant blank section there. So we kind of move everything over so that it can pull together a little better. So let's go back and take a look at this graph. And as we're looking at it, let's take into some consideration about what the data sets are. Now we notice that one on the x-axis, the years of work experience. That's a data set, and the hourly wage is the other. So let's ask ourselves some questions. Is there an outlier involved in this data set? Well, we see one right up here. Our outlier is saying that somebody who had 2 years of experience was making $30 an hour. That's a very specialized job, and that's probably why they're doing that, but that doesn't seem to correlate with what's going on here. Well, speaking of correlation or association, when we look at everything, as the years of work experience keep rising, 2 years, 3 years, 4 years, and so on, we notice that the hourly wage is also going up. So we can describe the relationship as years of work experience increase, the hourly wage increases as well. Now, what we can do, and when we're describing a relationship, it's important to make sure that when we're using our data sets, we mention our data sets in our description of the relationship. We also, if in this association here, and we're going to say right here, this association happens to be a positive association because they're both going up as years of work experience goes up, the hourly wage goes up. Because that's a positive, we want to make sure that we are showing the same word describing each data set. So because they're both going the same direction, we're going to say they both use the word increase. We could use rises, more, larger, as you know, we want to see the exact same word because we're talking about a positive relationship. Let's take a look at one more and answer similar questions. Here I did this with my class. We took a look at book spine width and we measured it in centimeters, and we took a look at the number of pages. We did come up with, let me get a little table here. We came up with, these are some of the data we came up with, and here we have the book spine width and the number of pages. So let's put these numbers on the graph. So here I have 0.5 and 110, 0.7 and 85, 1.8 and 252. And again, these are approximates, 1.6 and 195, 3.9 and 558, 2.3 and 325, 0.7 and 221, 1.1 and 115, 1.5 and 251, 1.7 and 260, 2.5 and 282, 2.6 and 316, 3.9 and 712, 1.2 and 55, and 1.5 and 126. So this is some data that my class came up with as far as measuring some book spine width and the number of pages. And again, we'll take a look at this and determine what kind of relationship does this have. We can see that as the book spine width increases, which is as we're going this way, we're noticing it increases, the number of pages also increases. Because of that, we can say that there's a positive association between book spine width measurement and the number of pages. We also, when we describe the relationship, we would say that the number of book pages increases as the book spine width also increases. And again, we would use the words from the data set, book spine width and number of pages, and we would use the exact same term because we're talking about a positive relationship. So we'd use the same term again.